Final section in Chapter 5 takes us in a slightly different direction. It does still have something to do with exponents, but we're going to be looking specifically at scientific notation. And before we can start doing that, we need to do a quick review of what it means to multiply a number by a power of 10. So in this first example, we have 1.745 being multiplied by 10 to the third. Well, that's the same. If we do this with order of operations, we would apply the exponent first. So 10 to the third becomes 1,000. And to multiply this number by 1,000, we're just going to move the decimal place 3 places to the right. This number is going to get 1,000 times bigger. So this becomes a 1,745. Looking at our next example, 1.07 times 10 to the negative 2, think about what you've just learned about negative exponents. I would rewrite this as 1.07 times 1 over 10 squared, moving that 10 to my denominator by using the negative elevator pass. And that's the same thing as 1.07 once times 1 over 100, or 1.07 divided by 100. And when we divide by 100, our number gets 100 times smaller. So our decimal point is going to move 2 places to the left, making this final answer a 0.0107. Okay. Scientific notation gives us some shortcuts for being able to do all of these steps. So let's look at a couple more examples of multiplication, and then we'll see if these shortcuts would apply back to the problems we just tried. The shortcut is to say that the exponent tells you how many places you're going to move the decimal, and its sign tells you in which direction. So this negative 7 says move the decimal point 7 places this way to the left, making that number 7 or 10 to the 7th power times smaller. So the first thing we have to recognize is that our decimal point is right here at the end of the number. If we're not given a decimal, that's where it's at. And when I go to move it 7 places to the left, I will end up at 1, 2, 3, 4, 5, 6, 7. Looks like I'm going to need 1, 2, 3, 4 zeros to hold my place before I write the 9, 4, 5. Okay. This number has a positive exponent, so it says we're going to move this decimal point 3 places to the right. Remember again, if you're not given a decimal, it's not at the beginning of the number, it's at the end of the number. So there's our decimal point right there. And if I move it 3 places to the right, I'll have to add 3 zeros for you to be able to see it. So let's go back and look at these first 2 examples and see if that shortcut would have worked. Sure enough, if I take the 1.745 and move the decimal 3 places to the right, my new number becomes 1,745. And in this example, if I move my decimal 2 places to the left, my new answer does become 0.0107. So now let's talk about the second objective, what it is to write a number in scientific notation. Well, scientific notation gives us a way that we can write very big or very small numbers. And by very big, I mean numbers like the number of inches that it would be to get from here to the moon, which is going to be in the gajillions, if there is such a thing. Very big numbers. And it also lets us write very small numbers. Okay? So if we wanted to measure the number of inches that an electron is, that is such a teeny tiny part of an inch that it's going to be a 0.000000 with lots of zeros happening. So these numbers occur in science a lot, and scientists wanted a way to write them that didn't make them write all of these confusing zeros. So all scientific notation numbers come in this form. There's a number out front. A is always a number. Okay. And then after it is always a multiplication sign and a 10 and then an exponent. Okay. So it's A times 10 to the nth. Looks a lot like these examples that we were looking at above. But there's a couple of rules we have to follow in order for that number to truly be in scientific notation. The first one is that A has to be between -10 and +10. And what I mean by that is that A has just one digit, and it's a non-zero digit, in front of the decimal. Okay. So look at the examples that we had so far. This first one, 1.745 times 10 to the third, is in scientific notation because there's only one digit that's to the left of our decimal place. This number is also in scientific notation, 1.07. We've got just one digit that's to the left of the decimal place. These two numbers are not in scientific notation because if you remember where our decimals were, this decimal was after 3 digits, this one after 2 digits. And in order to fit the definition of scientific notation, only one of those digits could have been in front of the decimal place. So now let's look at how we would write numbers in scientific notation. So we've looked at taking numbers that are in scientific notation and putting them into what we call standard notation, just the standard old way that we used to write numbers. Now how do we go the other direction? If we've got a number in standard notation, how do we put it in scientific notation? Well, what we're going to do is the same process that we did up here. We're just going to do it in reverse, moving that decimal until there's only one digit in front of the decimal place that's not a zero, and then counting the number of spaces that we moved it. Now this is the place where most students are going to make a mistake if they make one. You think because you're moving your decimal to the left that your number's getting smaller, so your exponent should be negative. And it's exactly the opposite of that thinking. This number, when we're starting with it, is a really big number. If my checking account balance was at $150,000, I would be pretty happy about that. So big numbers have positive exponents, and it's the really small numbers, like 0.0000678, that have negative exponents. If it helps you remember it, think of that this bank account would make you very positive, very happy. This bank balance would probably make you pretty sad. So let's look at putting some of these into scientific notation. Our goal is to get our decimal place right here between the 1 and the 5. So 1.5. And that means I'm going to have to move it 1, 2, 3, 4, 5 places in order to do that. So I'll write times 10 to the 5th. And again, it's positive because the number I started